Welcome to the MESA Robotics Competition 2025 through 2026. We are Los Pollos 3D from Calexico High School.
The members of our team include
Christian Tiveros, teleoperator.
Joel Escalante, the lead engineer.
Christopher Quintana, human player.
And Jimmy Vargas, computer scientist.
The competition will be split into two main challenges. The first one will be the teleoperator, and the second will be the autonomous.
1. In the teleoperator challenge, teams will need to score as many points as possible by shooting golf balls into their assigned baskets.
The team's robot will have to shoot from behind a marked blue line. You can also shoot from behind a marked green line on the floor to get double the points for the shot.
This challenge is difficult because you need to carry a golf ball and shoot it into a rapidly rotating basket while avoiding accidentally scoring in the other team's basket. The addition of the rotating basket makes the challenge much harder.
1.
It demands precise aiming and good timing. Any ball that accidentally lands in the other team's basket gives those points to the opponent team.
The challenge becomes even tougher when a team tries the 2x multiplier shot from behind the green line. Missing the target in this case means losing the bonus points. It also means potentially handing easy points to a rival team.
Round 2 begins, which is a two-part robotics competition. First, the autonomous challenge. The robot must autonomously identify and transport the single golf ball to a randomly placed red drop-off zone.
Signals completion by making a sound or waiting near the zone for 3 seconds. Second, the team proceeds to the teleoperator 40-point challenge using the robot to score the remaining golf balls and one marble into the goalpost. The round ends when 40 points are reached or time runs out.
When brainstorming and testing different methods of launching the golf ball, we decided on two possible solutions: a catapult and a mechanism similar to a tennis ball launcher.
Researching player devices, we looked at the video provided by MESA to get an idea and other dispensing devices from other sports like golf. We ended up testing multiple different models, such as using a cardboard ramp that makes the ball fall down and land on the catapult or floor.
We also tested out making a 3D version of the cardboard dispenser to do the same task as the other one, but made the hole for the golf ball fall through tighter so it was more accurate.
The launching mechanism involves two wheels spinning rapidly in opposite directions to launch an object forward. The catapult mechanism uses rapidly rotating gears to make the arm move with enough force to launch an object.
The design we chose for our human player device was to make a ramp that leads a ball into a hole, which drops it into our catapult. The first problem we encountered when building the robot was the drift. We struggled with this for a while until we decided to add weight to the sides of the robot in order to put more pressure on the wheels, causing less drift.
Problem we had was the launching mechanism. We couldn't get the wheel spinning fast enough to launch the ball, so we opted to make the catapult mechanism instead.
At first, the catapult was very inconsistent with how strong it launched. So we added more gears to make it stronger, but we accidentally made it too strong, so it was able to launch the golf ball all the way across the field.
Finally, we found the correct number of gears needed for the catapult for it to be consistent when launching the golf ball into the net.
Competition logistic rules define how the event runs. Teams assign rules and the robots are impounded after check-in, with a prohibition on later modifications.
The competition has 2 rounds, 5 minutes for round 1, 7 minutes for round 2. Round 1 is fully teleoperated and round 2 begins autonomously.
Rules strictly prohibit interference with other robots. Interference penalties escalate to disqualification. Teams must stay within the assigned lanes during the autonomous play. Failure to do so results in disqualification.
Teams must genuinely attempt the autonomous challenge for the 1 full minute or forfeit all round 2 points. Resets are permitted during play, but sometimes continue. All matches start at the judge's signal. A false start led to a match restart.
Robots are often used for training in sports like soccer and baseball. In these sports, automatic ball launchers are used to test reaction time. Additionally, systems like video assistant referees, VAR, are used to observe sports games and point out errors.
Aside from sports, robots are frequently used in factories and high-stress environments. In factories, robots are utilized to maximize efficiency in producing goods. In high-stress environments, robots are utilized when the area is too dangerous for humans to work in.
In our robot, the code is used to make the robot follow precise instructions to complete tasks, such as in this portion of our code. Here, the robot is instructed to move forward and grab the ball placed in front of it.
This program controls the robot's autonomous movement around the field. while following a planned path using driving and turning commands.
The claw is used during the run to grab or release game objects. An optical sensor is turned on at the start to detect colors.
The sensor continuously checks for the color green as the robot moves, and then when the color is green is detected, the robot reacts to the detection.
It backs up and moves the claw in response to the detection, then plays a sound to confirm the action was triggered.
This video was brought to you by Los Pollos 3D from High School. Thank you for watching.